In this video, we're going to be taking a look at correlation between a set of bivariate data. Now again, a set of bivariate data is just simply measurements based on two different sets of variables. So here in this application, our first variable is advertising and the second variable here is sales revenue. Now we want to find the correlation between those two variables. So here, a certain store located in Welland, Ontario wants to determine the effect of advertising on sales revenue. So the following data represents the sales revenue, which is in thousands of dollars, and the advertising expenditure, which is in hundreds of dollars. So here, the advertising of 1 represents $100, and the sales revenue represents here $1,000. So find the correlation coefficient between those two variables. So what does it mean to find the correlation between two variables? Well, for example, the claim is often made that the crime rate and the unemployment rate are highly correlated. Now, the term correlation implies that you have a relationship or an association between those two variables. So we want to see if there's a relationship or association between these two variables of advertising and sales revenue. Now, the correlation coefficient tells you two things. It tells you whether or not you have a positive or negative association between the two variables, and it also tells you your strength between the correlation of the two variables. So for example, it could be a weak correlation, a high correlation, or a moderate correlation. So we're going to go ahead and obtain the correlation coefficient. Now from the least squares trendline video, we actually used this exact same set of data and we obtained these sums from that video. So go ahead and take a look at that video to see how we obtained those sums there from this data. Now in this case, I'm labeling your sales revenue as your Y variable and your advertising as your X variable. Now with correlation, it really doesn't matter which one is labeled X and Y, but for the sums that you see here, I have labeled X as advertising and Y as sales revenue. I want you to now pause the video and based on this information, obtain the coefficient of correlation. And remember that the coefficient of correlation is found by this formula here. We generally let R represent the correlation coefficient. And so here's the formula. Pause the video now and obtain that correlation coefficient on your own. Okay, so before we start applying our summations into our formula, I just want to point out one thing. There is a major difference between the sum of x squared and the sum of x all squared. The difference is this, that the first one here that I'm circling is each individual x value squared and then added up. So we would square 1, square 2, square 3, so on and so forth, and then add up those values. Now that summation here works out to be 55, so this value here is 55. Now the second summation, the one that I'm circling now, is different. The sum of x then squared, which means that you would have to add up 1 plus 2 plus 3 plus 4 plus 5. And then you would then square that resulting answer. So this sum would be 15 and then square that value of 15. So let's go ahead and plug in all the necessary information into this correlation coefficient formula. Now in your numerator, you should have got n, which is 5. The sum of your x times your y is the value of 37. Minus, now the sum of your x values is 15, the sum of your y values is 10, and then we need to divide this by what's in the denominator. And so this needs to be divided by the square root of n, which is 5, the sum of your x values squared, so that's the individual x values squared, would be 55, minus the sum of your x values then squared, so that would be your 15, and we would square that. Multiplied by another square root, basically the same thing but of your y variable. So 5 multiplied by your y's squared, which is 26, minus the sum of y, which is 10, and we're going to square that. Now here our numerator will work out to a value of 35. Your denominator under your first square root, you should have obtained a value of 50. And under your second square root, you should obtain a value of 30. Now this works out to be approximately 0.9037. Okay, so what does this value, 0.9037, actually mean? Well, yes, it's your correlation coefficient, but what does it tell you about the association between the two variables of advertising and sales revenue? Well, this value of 0.9037 just simply states that we have a positive, strong correlation between X and Y because your value is very close to 1. Now there is a measurement scale used to describe the correlation coefficient. So if we see down below here, this would be the measurement scale. Now your correlation coefficient R is just simply a quantitative measure of the strength of the linear relationship between X and Y. Now that measurement could be positive and it could be negative. Your value of R should always lie between -1 and +1. You should never obtain a value larger than 1 or smaller than -1. So you'll always lie between this interval here. Now, if you lie between 0 and 0.5, that just suggests here that you would have a weak positive correlation because it's positive. Now, if you were to lie between 0 and -0.5, that would suggest a weak negative correlation. Now, if you were to lie between 0.5 to 0.8, that suggests a moderate positive correlation, and then from 0.8 to 0.1 suggests a strong positive correlation. The same goes on the negative side. Now for our value of R, we have a 0.9037 value, which suggests that we have a strong positive correlation between the two variables of advertising expenditure and sales revenue.